Hey, hi Tyler.
Hi.
So we'll start the session at within like next 7 minutes.
Already. Sounds good.
Yeah, so there are people still joining in. We have given a deadline of 7.
Sure. Okay. Sounds good. Um, would you like me to share the slides? I can do the presentation part if
Uh,
that's what you want,
so
or do you want to share them?
so from our side, Pavitra will be joining, and
Okay.
she will be walking through for the first few slides. Then we'll
Okay.
hand over to you.
Great. Hi, Sumona.
Hey, hi Tyler. Hi Sumona. Hi Christine. So we'll start
Hi.
the session in next 2 minutes. So we are still
Sounds
waiting
good.
people to
Yeah,
join
sounds
in.
good. Hmm.
So unfortunately, just a minute back, I got an information like Pavitra is not available for the session. So I'll be
Okay,
taking over.
sure.
Sure.
Hi, Sumona ma'am. How are you?
I'm good.
Hello.
How are you?
Good, good, good.
Yes. Good to see
So,
you.
yes, yes. So long time we met and spoke.
Yeah.
Hmm.
Long time means March, right?
Yes, yes.
Yeah. Fantastic. Yeah.
Okay, okay.
I'm
Fine,
looking
fine.
forward of my
Yes, yes.
January trip.
Yeah, yeah. We will plan it accordingly.
Yes.
Hmm.
Fantastic.
So, hi, Christine and Tyler. I'm Gautam.
Hi, nice to meet you.
Hi, nice to meet you too. So, we were actually this thing. When Sumona came down here, we were taking her to colleges.
Okay, right. Okay,
Okay. Fine, fine. So I
great.
think it's time for us to start with the session.
Sure.
Absolutely.
So yeah, we will.
Hello, everyone, and welcome to today's extraordinary session with Clarkson University professor on data science. So, before we get started, I just wanted to get a cross check from you guys whether I'm audible to you or not. I request everyone to post their answers on the chat box. This chat box should be very active today and it should be an interactive session. I see yes is coming in. Okay, it's time to get started. So as you all know, like today we have Clarkson University professors going to share their insights on data science. So before getting started, here's a quick glance about Galvanize. So what we do, we help with end-to-end personalized solution for students and working professionals aspiring to pursue a global degree abroad. We help with profile building, we help with test preparation, and we also help with admissions counseling. The team is managed and founded by alumni of Stanford, IIT Madras, and IIM Ahmedabad. The students from 65 plus countries have chosen Galvanize for their study abroad journey. You can see the countries, it's in the alphabetical order. We have enabled our customers to reach 1,000 plus universities across 18 plus countries. You see US, Canada, Australia, UK, Germany, France, name the country and we are here to help you. Up next, we have a worldwide user base. We have 1 million plus users for a mobile app from 195 plus countries, a global rating of 4.7 out of 5 on both Play Store as well as App Store. I'll share you the Quora feedback link on what students has to say about Galvanize. So it's time for the first poll. So just give me a minute. I'll just pull up the poll. So yes. So here's the first poll. How interested are you to pursue your higher education abroad? I request everyone to fill up this. All right. So I request everyone to fill up the answers. The poll will be active for next 10 seconds. Here we go. So almost 50% of the students are planning to study abroad and 30% are considering it but unsure. Okay, so your answer will be sure after this session, guys. So here is about Clarkson. Clarkson is a private research university with its main campus in Potsdam, New York, USA. Ranked as a research university, very high research activity, R1 by Carnegie Foundation. Ranked as a top tier national university by US News and World Report and best colleges. Ranked 45 in the best schools by US News. It has an acceptance rate of 75%. So here you go, introducing the panelists of the day. We have Sumona Mondal, who is a co-director MS program in applied data science at Clarkson University. We have Christine Gohl, Professor Data Science at Clarkson University, and we have Tyler, who's the Director of Projects and IT Infrastructure at Clarkson University, US. So without wasting any further time, I hand over the mic to Sumona, Christine, and Tyler.
Thank you. Thank you, Sahil. So, Tyler, if you would like to share.
Oh, okay. Yeah. So
Yeah.
I can share
I
my
will
screen. I
just
wasn't sure.
exactly.
Okay.
Yeah. I will just
Alright.
ask you to go next. That would be easier.
Awesome. All right.
Excellent. So it's a very good evening to everybody over there. I'm Sumona Mondal. By the name, you definitely can feel that I'm exactly like you. I came from Calcutta, India to United States 19 years back to pursue my PhD in statistics. I'm just giving my introduction first so that I can connect with you easily. And then I started my PhD, and after that, I finished my PhD and I joined Clarkson University as a faculty member in the Department of Mathematics. After a few years, me, the director, Professor Boris Jukic, then Tyler, and there is another professor in our mathematics department, we sat down and decided, well, let's do something different. And we came up with the plan of this data science program that is around 8 or 9 years back. And after that, the program started well. But initially, it was few students, and we are getting students from all over the country, but definitely mostly from India. Last 3 years, during the COVID and after the COVID, we see a surge in the data science. And of course, I know the pulse of the students from India because I'm from there. And I see that the students are very much interested in the data science program. And at the same time, we have innovated well in our program. We have designed it so well. We have taken off from that time onwards. Our students are performing very well at Clarkson University. Our students are doing excellent after they are graduating, and we are getting excellent students and interest from India especially, and of course all over the world. So just to give you a quick glance of Clarkson University, Tyler, if you go back to the first slide, yeah. It's very simple. I'm just going to tell you what Clarkson University means to us and what will mean to you when you join. We are 127 years old, technically. So that means Clarkson University was inaugurated in 1896. It's an old school. We just celebrated 125 years of leadership. It's a private university. It's a very research-focused university. And at the same time, we offer different rigorous programs in engineering, business, arts, education, and health sciences. Where we are located. So when you think or hear the name New York, it's absolutely not necessarily that it has to be New York City. I had the first impression when I heard about Clarkson, well, New York means New York City. No, absolutely not. So you see New York City in the map here, and you see Potsdam, Clarkson main campus, which is practically close to Canada. So we are far away from the New York City, but we all love New York City. We visit and go there often. This place is fantastic, especially at this time of the year. This is our summer, which is kind of the winter time in India. So you will feel a really nice temperature and everything here at this point. But of course, our winter is special. When you come here, you will enjoy that too. Other than the Potsdam campus, we have a campus in Capital Region. Then few things that we have in our Clarkson University. Tyler, if you can go to the next slide. We have very high rating of the job opportunities among the students when they graduate. Clarkson does a fantastic job in bringing alumni and bringing companies at our career fair, which occurs actually twice a year, generally in September and February. So there are companies who are coming here to talk to you. This is probably the most fantastic opportunity and the job that Clarkson provides, which is excellent. And thus our students get jobs very easily. So we have 1 in 5 alumni who are leading as a CEO, president, owner, or senior executive in a company. And of course, they start with high salaries. The point is that Clarkson is very much focused on the technological degrees. We have very prominent and research focused and very popular engineering degrees at Clarkson. You can think about every other department has a PhD program. That means our students are very much focused. And of course, our master's program are all cutting edges. These are some facts. We will share the slides with you. You can find it. They are all over. They are all over the internet. So I don't need to tell. Now, coming back to us, we are the team. And I think from here, Tyler will continue and describe what we are, what we do, and what are our future. Go ahead, Tyler.
Yeah. So thank you, Sumona. So one of the really things that I love about our program is that we each kind of have our areas of focus, and these things overlap quite well in the data science field. So this is really important because, of course, data science is very multidisciplinary. So we have a lot of people, students with backgrounds from engineering, business, mathematics, right? So we all as faculty are very diverse in that kind of kind of in our backgrounds. So that's to the advantage of the student. Yeah, we've grown the number of faculty quite a bit in recent years. So here we all are. I'll kind of just briefly discuss. So as Sumona mentioned, Boris Jukic is our kind of director of our program. In the recent years, Christine, Mike, Bhavana, and recently Tavasha have all joined. I've been teaching in this program for since we created it around 2015. My background is really in the engineering side, so Python, sensors, collecting data, right, for close to the data origin. So I'll give a little bit more background about this a little bit later, just so you can kind of think about the field and kind of have like a mental model of, what things you might want to pursue in this field. Christine's joining us. So I'll just kind of go through. So Christine focuses on data visualization, does a lot of R, Tableau, of course, and so Power BI as well. She'll go into a little bit about data visualization in her slides. And I guess so Mike just joined, Mike Gilbert. So he does a little bit more Python. Bhavana does works with SQL. She does some ETL. She keeps track also, very importantly, of our internal data in our program, which is extremely important for us. That's been huge. And Tavasha just joined. She's comes from kind of a more math and statistics background. So we're very excited to have her on the team. So I'll go through, so we talked about the faculty. I'll talk just again about the layout of the roles and titles for working with data. And again, what I say here isn't going to be, what everyone might agree on, but it's a good way to think about the different fields and different career paths that you might have in data science. A lot of students ask me about that, so I'll dig into that a little bit. We've picked kind of 3 focus points. So these are 3 topics in the industry. I think, so I'll talk about this data transformation. Christine will talk about data visualization, and then I'll come back and talk about AI and alignment, which is kind of of course, very popular topic right now. We'll talk about kind of why Clarkson, and then we'll give a little bit more details. And what we really want to do is open the floor up to any questions at that point. So we're really going to try to make this short and concise so that you guys can ask questions. So if you have questions along the way, jot them down, send them in, and then we can answer those, circle back to them. That's my favorite part of this. So what is data science, data analytics? So really, this is about extracting value from the ever increasing amount of data that we have, right? So, data is everywhere in every single field. So one of the things that I like doing, I come from kind of a consulting and kind of engineering background, I like to build applications and collect data and work with data from lots of different industries. And this is something that you can do, of course, in the data science field. Actually, it used to be kind of like these fields, right, really focus on data. But at this point, really, it's hard to find a field that doesn't. Right. So, I mean, for example, agriculture, right? This is probably one of the most data centered fields, right? So you can kind of try to get away from it, but it's pretty hard. There's almost no field that doesn't incorporate data in some way. And one of my favorite things in consulting for small organizations has been seeing organizations that didn't leverage their data, right? And kind of demonstrating to them how they can leverage that data and generate value, right? So this is really what we're trying to do, value extraction. So all the things that we need to do to extract that value from the data. So I like to break the data fields into these kind of three categories. So again, it's not so much that you absolutely take every job and task and put it into one of these buckets, but it kind of helps you think about this kind of three field layout. So the first is data science, the second is data analytics, and the third is data engineering. So I would say that data science very often is used as an umbrella to encompass many of these other fields. Analytics is definitely on the business facing side. Visualizations usually fall into this category. Communicating ideas, really super important. Data science, many times, I would say at the high level, data science is really about the kind of very math and statistics, building a hypothesis, and then testing and proving that hypothesis. So very, again, science driven oriented. And then there's kind of my field, data engineering. I would say in the last few years, data engineering has become super important. There's a tremendous amount of infrastructure out there that needs to be maintained, and a lot of data needs to be transformed. So of course, I'm very biased, so I'm going to say data engineering is very important, but we all come from our own kind of backgrounds in these various camps. And so we all are going to have our own opinions about them. So I'll talk more about these focus topics here, at least two of these. So we'll talk about transforming big data into smart data. So this is kind of on the data engineering side. We'll talk about visualization. So again, this is more on the analytics side. And then AI and alignment is probably encompasses a lot of these, but I would say maybe we could attribute that to data science. So here's this couple images from some of the proprietary data that I collect. So by the way, I do a lot of research with students directly on data sets that I've collected. We just installed a 30 terabyte server in the data center here at Clarkson, where we store all this stuff. We haven't filled it up yet, but we have probably about 5 terabytes of data in there that we use extensively. This is data that no one else has. This is stuff that's collected by my systems. So I like to work close to the origin of the data. You might capture an image that looks like this on the left. So what do we care about? Well, we care about, how loud is that vehicle at that exact moment in time, right? What kind of vehicle is it? What time did it cross the line? How fast was it going? What direction was it going? We might so this would be a transformation, right? So extracting some insights, right? Because the raw image is not particularly useful, especially when you have 300 million images. You can't do a whole lot with that, right? You can't have a person sit down and look at every single one. So, we build tools to kind of extract these insights from the data. Here's some example of this is kind of like nested data down below, and we have sound data over here on the right in 2 different domains. So I'll talk a little bit about domain transformation. So we can kind of transform data from one domain to another, and this helps us extract some features, right? So a lot of these tools and techniques are going to be super useful. When we think about data, like where it comes from, right? The origin, I talked about the origin of data. We really have I would say there are really 3 main data sources out there, right? So there's data lakes. These are really just files on a file system. This could be on Amazon S3 storage. Many of you probably have already worked with AWS in one capacity or another, but it could be on some internal file system. These are basically just files that are not organized in a really great way. Maybe it's a bunch of image files, something like that. Sensors. So these could be raw sensors out in the field. There's a couple examples of sensors over on the right with the how inexpensive these sensors have become. It's absolutely, there's a huge amount of data, and a lot of work that I've done in the past has been about using these sensors to collect data and send it off to some server. But there's also a lot of pre-processing and I guess post-processing after that data is captured from those sensors that needs to happen. And then the kind of third area that we get data is from a transactional database. So transactional database might be an application. It might be an e-commerce application that you have. And that e-commerce application might have a relational schema. And so we work very heavily with this in our various classes, learning how we can kind of draw insights from that, right? You think, oh, I have the data, I can draw insights, right? So no, it's usually not like that. Usually there has to be a tremendous amount of transformation that has to happen before you can extract really anything, even something pretty simple. So really, these are kind of the three areas where we see that data coming from. And in our program, I have lots of sensors out in the field that all comes into our our server where we use it. And ultimately, it's actually the sensor data ends up being stored ultimately in a data lake. And then, in some of my classes and Boris's classes, we extract a lot of data from transactional databases. And then once we've extracted it from these sources and kind of transformed it, now we're ready to do some of the analytical things, right? We can get into the statistics, we can get into some machine learning and that sort of thing. So I mentioned it comes from these raw sources. We have to transform that data to put it into some other system, right? So what types of, when you say transform, like what does that mean, right? So I've kind of decided there's like kind of 4 categories here of types of transformations. There's pure format. So this could be something like it needs to go from CSV to tab separated values, right? Comma separated values to tab separated values, or JSON or something like that. Purely mechanical. You could pretty much write a program to do it. We do a little bit of that. We think about some interesting problems around that. Schema changes. So this would be more of a logical change. So changing the way the data is laid out, right? Going from something nested to something flat, right? So what is it? So these are all kind of things that we think about. These are really super essential skills here if you're going to work with data in any capacity. Then we have things that are a little bit more advanced. So domain changes. So if you look at like this sound data, right? This is amplitude over time. And this is amplitude, and on the y-axis here is now frequency. So it's kind of, we're binning the frequency distribution across time. So we can see the constituent frequencies that make up a certain sound. This is much easier to work with in many cases for a lot of reasons than this is, right? For one, we can use image recognition on this, right? And there's already a bunch of existing image recognition models that are out there. So we can kind of leverage those to work with our data. Whoops, going way past where I should. And then the last one is feature engineering. So this is something that we use in machine learning pretty extensively. And this gets a little bit more into depth. There's a lot of really great, I think almost all really good machine learning ultimately is hinged on really good feature engineering. And this is actually what we focus on in Mike's machine learning class is, how do you do that good feature engineering? That's the part the human can really apply a tremendous amount of value for, is how to engineer these features. All right, so we'll talk about, so Christine will talk about information visualization now.
Thank you, Tyler. He gave me a little bit of an intro too before, but I'll introduce myself. So I'm Christine. I teach InfoViz. I teach probability and statistics. And then in the spring, I'll also be teaching database modeling. All of these are core courses in our program. I have a little bit more of a background in the business realm. I worked as a data analyst and a project manager. I also do some consulting in those areas. Tools that I frequently use are R and RStudio, Tableau, and SQL. So I'm going to talk to you guys a bit about information visualization specifically. So we'll start here. InfoViz is kind of just sometimes an overlooked but very important area in the field of data science. It's kind of a broad term, but really what it is it's creating visual representations of abstract data. So it's going to combine elements of design, of computer science, and data analysis that's going to shape data into a visual context. So graphs, charts, maps, interactive dashboards, these are all what allow us to take complex data and share it in a way that people can understand or analyze it. Some of the key areas of InfoVis that we teach as part of our core program are design principles, for clarity and efficiency of sharing information. Interactivity, so to allow users to explore and manipulate things, like zooming, filtering, and then also the tools and applications. So things like Tableau, Power BI, and also some programming languages like R and Python. These are all areas of InfoVis that we study. So this here is an example of visualizations from a US elections data set. So this is actually something, pulled from class here. We're using techniques to develop iterations of a scatter plot to kind of reveal counties that flip from one election year to the next. You might be handed a data set like this and use visualization techniques to create a meaningful graph. So you can kind of see the progressions where we narrow down to focus and see which counties flipped in a certain election year. The main goals of visualizing data are, one, simplification. So designing to make complex data more accessible and easier to understand. Drawing insights. So that would be, an example of what we're seeing here. Creating visualizations that are going to reveal patterns, correlations, and trends within the data. Decision making. So sometimes visualizations needed to support some kind of data-driven process. And communication. So using visualizations to effectively convey information to a broad audience. You can flip to the next slide there, Tyler. Okay. So here's another example. So we study InfoVis, to be able to recognize and mitigate problems in design. It's really important to always truthfully and always clearly represent the data. So in our class, we talk about, 3 main categories of issues that visualizations commonly have. They often have problems with their aesthetics. So that would be, unattractive or inconsistent design choices. They also have substantive problems. That's where there's issues with the data that's chosen or, purposefully left out. And then also perceptual problems is the third one. This is, when the visualization is confusing or misleading and how it's perceived or processed, based on, our human characteristics. Most poor visualizations are going to have more than one of these problems in their design. So in our class, we review and we discuss many visualizations from many sources. Students bring in ones and we discuss them. This is an example of something that we would interpret. What might not be obvious about this graph here from the New York Times is it has substantive issues that are going to make the results of a survey misleading. So here, some fields are kind of being cherry-picked and not represented clearly. This is a graph based on a survey that asked, on a 10-point scale, opinions about democracy. So respondents had to answer on a 1 through 10 scale of how essential democracy is. In this results graph, though, that percentage scale is kind of misleading. We don't know if some decades maybe had a larger response pool than others. And also, what you don't know here is that essential in this graph is only people that answered a 10. So people that answered an 8 or a 9 are not being considered. So, including the average point scale response per age group would have been a more truthful way to represent this data. So people with the answer close to a 10 would be represented. And that's the type of thing that we discuss in class and that, we have to think about when making visualizations. You can go to the next slide. Thank you. Okay, so again, because data visualization is useful and necessary in so many different contexts, and it's also needed for all different ability levels, it really makes sense that there's so many different tools out there that have really a broad range when it comes to how easy or how complex they are when it comes to the ease of use. These are just, a handful of some of the most popular ones. You'll see here a mix of, general purpose ones, business intelligence tools, open source platforms, programming tools, there's so many different ones. And because there are so many, we teach and require just a handful of these, but, we always want you to explore and try other ones out. I'll talk about a few of the ones that we use in our course. From day one, we start using R in our studio. Our studio is an integrated development environment for R that provides like the user interface and the tools. R is the language that's used behind it, and that really has very strong analysis, computing, and visualization abilities. It's open source, it's widely used. It's It's available for most operating systems. And because of that, it's very frequently maintained and updated. So that's the one that we primarily use in our class. Our Shiny apps is another major tool that we use. Oh, someone raised a hand. I don't know if I'm supposed to answer questions right now. I'll keep going. Our Shiny apps is another major tool that we'll use. That's just a package within R, so that allows users to build interactive web apps. This allows data scientists to, make interactive visualizations and dashboards that can be shared through a web browser. So you don't have to have R on your computer to be able to work with those and play around with them. Tableau is another one that we'll use primarily in that class. More commonly for business intelligence settings, works well. It integrates very well with databases, spreadsheets, cloud services. It's different from R in RStudio because it's not a programming-based tool. It's known for being, very user-friendly, has a wide range of visualization types. Again, it's used extensively in business. In our class, we'll also use Power BI and we'll also use Excel. I won't really go into depth on those, but those are the tools that we use and require in our class. I think I will hand it back off to you, Tyler.
Great, thanks. Yeah, and I mean, I think that we all kind of use this to some degree as like the best way to kind of learn something many times is to see how to not do it, right? And so that's why it's really important to study visualizations where there might be something better that they can do. So that's a huge, and I always joke when I taught machine learning, it was like I didn't teach how to use machine learning, but how to not use it. In other words, what things you don't want to do that are pitfalls, because those are actually the kind of important, super important things. So I think many of us follow that. So so I'll talk a little bit about AI, right? So AI is essentially machine learning to a higher degree, maybe. I will kind of, there's really kind of a couple of really important topics in the world of AI. These are actually mostly not super technical topics, but I want to just mention them because we'll circle back and talk about kind of why they're important, but also like why our program is very relevant with these kind of AI topics. So there's 4 of them here that I've called out, and I would say, I'm going to focus on just this first one. So introspection transparency. This is about kind of not making a model that's black box where we kind of know what's going on with the model. So it makes a decision. Why did it make that decision, right? Many models, it's really hard to know why it made that decision, right? We don't want that. That's not good. Alignment, right? So this is actually sounds pretty simple, right? So this is basically the model does what you want it to do in different circumstances. It sounds pretty simple, but it's actually super hard in many cases. Auditing validation. If somebody says, hey, I have a really good model, it's 99% accurate or 100% accurate, almost certainly it's not. And if you get 99% accurate, when students get that, I usually question that. And one of the other problems with measuring accuracy is in many cases with, say, imbalanced data sets, 99% accuracy, right? So if I'm trying to predict whether it's going to rain in a desert where it almost never rains, my model could just be, it never rains. And I'd be right 99.99999% of the time because it only rains one day every 3 years, right? So there's a real problem with kind of your metrics that you're using for validation and for measuring accuracy. And that's something that is a big topic in this field. And then there's perpetuation. You don't want your models kind of, if your model affects the real world, you don't want that perpetuating certain stereotypes and that kind of thing. So we'll talk just about transparency. So I have a good example of this. So I have actually 2 examples. So the kind of textual example that's called out here is this pretty famous case in the 90s. There was a model that was developed by Microsoft to decide whether somebody who comes into the hospital with a case of pneumonia, so respiratory distress, should stay in the hospital overnight, right, in the ICU, in the intensive care unit, or they should go home and just get some rest. So they built this model because the doctors needed to know, should we send the person home or not? And it could be a life or death situation. So they built the model, and it turns out that the model, they had all these different criteria, maybe age, gender, probably weight, body weight, all these other things. One of the things that they collected, one of the inputs to this model was, do you have asthma, right? So this is kind of this difficulty breathing under certain conditions. And what the model gave as a result was that if you have asthma, right, so a pre-existing breathing condition, that you should not stay in the hospital. You should go home, right? And this is exactly counterintuitive to what we would think. If you have asthma and you have pneumonia, you should stay in the hospital because you're at risk. But the model said you shouldn't. And so the question is why? And this is very important because, when you get such a crazy result from the model, do you just follow it, right? Or do you look into the model? Right? So you need to be able to look into the model, introspect that model, look at why it's making that decision. And it turns out in this particular case that they could see that the model was making this decision, and it was because there was a bias in the data. So what it turns out in this specific situation was that in the past, people with asthma would, in the collected data, they would automatically tell them, oh, you have asthma. The doctor would say, you have asthma, you should stay in the hospital. So because those people were staying in the hospital, they already had a much better success rate, right? So they had a much better kind of recovery rate. And so, this is a case of, we need to look into this model, see what it's doing, to get some insight into why there might be a bias or why it might be doing something unpredictable. So on the right side here, I have another kind of example of this. This is from image recognition. So we were trying to kind of detect vehicles. This is from a student project. We were detecting features of vehicles. And one of the things was, so model wasn't working very well. And we said, why is this model not working? So one of the things that we did was we said, okay, we used a technique to have the model show us on the image where it's looking, right? So this idea of saliency, where is the model looking? Where is it extracting its features from? And so in this image, the yellow spots are the areas that the model's extracting its features from. And you can probably tell here that the model is extracting features from almost everything on this image except the vehicle. And if we want this model to look at the vehicle and identify the vehicle, we want those features to be only on the vehicle, not up here in the trees, right? And this is actually really common. There's actually another case of this that I remember reading about, and it's a very common thing with image recognition. Very often features are extracted from the background, not the actual object that you want to detect. And so without this introspection, without being able to tell what the model's looking at, we could deploy this model and have no idea that it's looking at the totally wrong thing to make this decision. So this all comes back to kind of fundamentals, right? So again, right, there's many this is a new field, right? This field of AI, but very often it comes back to these fundamentals, right? Unpack, cleaning the data, construct analytics first applications and data stores. So these are kind of like places where you need to store this data to pre-process it. Understand the limitations of predictions, understand and identify the pitfalls, right? So this is kind of what I was just mentioning. Being able to have really sound statistical guidance, really thinking about how you visualize results. All of these things are things that we teach in the program in various classes. And all of these things are very relevant, even in kind of the new highly advanced machine learning or AI world. It all comes down to these kind of fundamentals. So I guess I'll hand it over to Sumona. You can kind of finish up and just talk a little bit about our program specifically.
Yes. So I will come back to specifically what our program is and what it offers. Definitely, since it's a professional master's degree that we offer, it is designed to fit the needs for the industry. We prepare students so that they can get jobs. That does not mean that if a student wants to pursue a degree in the higher studies for a PhD program or for any other master's, we do encourage our students to do that. And our program is very much interdisciplinary. If you just see our names and our attachment with the Clarkson University, I'm from the mathematics department. Then Tyler, Christine, they are from the business school. Professor Boris Jukic, also from business school. Then Tevasha, she's coming from the mathematics department. And we collaborate with every other faculty member in the university. They are coming from different disciplines. So we do work on disciplinary areas. What is the purpose and the advantage of that? You guys are coming from different degree programs, right? Your backgrounds are from different engineering degrees or other science degrees. We want you to train in the data science, and at the same time we would like you to get all different techniques and everything that you have learned during your undergraduate degrees to implement, so your job opportunities get much more higher. We have a strong support from the industry partner, as we have decided, and we have a very strong alumni connection. And we have designed our program to train students from a variety of professionals and academic background. Now, there are certain prerequisite courses because it's a data science or data master's in applied data science. You need to have some preliminary things that in your knowledge, and I'm very confident about our South Asian degree programs. You are good in math so that you can get into the engineering colleges. That I know very well. For that matter, calculus, probability statistics, and basic programming are the skills that you already have, and we also test on that. If you have forgotten things, then we have designed courses so that it brushes up your kind of the background and you are ready to start with the program that we have. Yeah, Tyler, if you go to the next slides, please. So this is just the website that we have, and you can click it when you get these slides. You can just copy the link and you get to the program. Now, this is the most important slides, or these few slides are most important slides. Why? Because we are now going to talk about what our program is. Technically, our program is for 36 credit hours. And most of the cases in US universities, each course is designed as 3 credit hours. So we have designed our program that has 6 core courses. All of us, me, Tyler, Christine, Boris, we teach some of the core courses. Some of the courses we have designed from the scratch. What are those? Database modeling, design and implementation, probability and statistics for analytics, applied machine learning, information visualization, data mining, and data warehousing. Why we do this? Because we think these are the preliminary and most important, most essential courses that every student needs to know that. You cannot avoid the core courses. You have to take these 6 courses for sure. And if you have background in, say, statistics, we will see that what are the courses you have already taken. We may waive that and we can ask you to go to the next level. So that is a kind of a big decision that we had made when we designed the program. Now, if you take 6 core courses, 18 credit hours are done. So we are left with now 18 more. So we go to the next slide. We can talk about what else we have, and then maybe we'll come back later to the previous slide. This is a slide that we are improvising and we are developing all the time based on the need of the industry and the time. Why? There are 4 electives that you have to take. Each of them is 3 credit hours. That means total 12 credit hours. Now look at the courses. These courses, some of them were already existing in Clarkson because Clarkson offers PhD program in almost all disciplines. And we are actually combining that in expertise so that our data science students can learn from different degree programs, different courses of their own interest to make their CV much stronger and get to the next level. Look at the courses: Modeling for Insight, Big Data Processing Cloud Services, Introduction to Big Data Architecture Application, Natural Language Processing, Application in Geospatial Analytics, Science and Engineering, Decision Analysis, Risk Management, then Artificial Intelligence, Computational Machine Learning, Advanced Applied Statistics, Deep Learning, System Analysis, Image Understanding, Pattern Recognition, Stochastic Processes, Artificial Intelligence, Human-Computer Interaction, Digital Signal, Probability, Applied Bayesian Analysis. These are just some of them. There are few more. If you are interested, we can definitely talk about that. So the point is that there are so many of them. You just need to take 4 of it, right? It is always kind of prominent from our experience we have seen. The students who comes from computer science background, they prefer more courses on the elective side from the computer science department. Students who are coming from civil engineering background, they take more elective courses from the civil engineering department. And we have developed these courses. We have talked to different professors so that it cater all our students. So we are done with 18 plus 12, 30 credit hours. Tyler, if you go back to the slide before, so we are left with, yes. So we are now left with 6 credit hours. That is another important aspect of our program, which is very unique and different from other data science program in other universities. We have 6 credit hours for capstone project. Most of the students, they work with me on the capstone projects. I give them very much research focused direction. I personally have a research group where I have 4 graduate students, PhD students from the mathematics department. My area of expertise is air quality monitoring, public health epidemiology, advanced statistical inference, and multivariate analysis. Those are the things that I have learned during my bachelor's, master's, and PhD in statistics. So I have my research interest on those areas. I have PhD students. They guide a lot to these master students. They work together and they take different direction on that aspect. Recently, we have seen that bioinformatics is taking up huge, and we are getting students who are very, very interested. This is all big data problem, technically big data problem. You need to know how to use a database. You need to know how to use machine learning. You need to know how to mine the data. So all the skills that we have in our program that helps students to prepare for the capstone project. On top of that, we have internships that can be counted as a capstone project as well. Students who are really focused on job, they try very hard to get the internships, and then their capstone projects is counted by that. So this is what our 36 credit hours program that we offer, and most of the students, they complete the degree either 1.5 year or in 2 years. That means they distribute the coursework over 3 semesters or 4 semesters. We are very flexible. There are few students who have completed the degree program in an year, but which is a little bit unusual. And at the same time, we offer online master's degree in this data science. So technically, if needed, any student in our in-person class can take an online course in case they got a job or they got an internship or they got a place where they start their work. So we have that option, but we have a group of online students also who goes through this program. Now, if we go to the next slide, Tyler, just yes, next one, please. So these are some of the research aspect that I have in my group. If you look at the 2 names, Graydon Shand and Leah Martin, they have finished their bachelor's in data science, and Graydon Shand has finished his bachelor's in business and at the same time master's in data science. They are working fantastically. So this is their project. They started with me in the data mining course, and we have continued with that. We had made it as a capstone project and we have published. So the point I want to make here, there is a very huge deep component of the students who can take these courses, can implement, and these are all real life problems. My problems in research, I take mostly from the health analytics perspective. I work with many medical science professionals, and on the epidemiology where big data is very prominent. The next slide is also, if you go to the next slide, please. This also a slide where we have rheumatoid arthritis data that we have. I have worked with a rheumatologist from the local hospital. We have published this, and these are students who actually worked as a data scientist. Now, I have a lot of projects that we initiated during the COVID time. So those are very interesting. Students like those. And now we are implementing and designing a lot of different projects on the air quality monitoring, because we all know that this climate change, this air quality monitoring is getting very important. At the same time, it is important from the South Asian perspective as well. So there are different aspects of the research. This is just a small sample that I'm talking about. I'm talking about my part. But now I think we are good to go with the program and what we do and what are the techniques that we have. Anything any question right now you have, please go ahead.
Yeah, thank you, Sumona. And I did get a couple follow-up questions about, data science versus analytics. Actually, one thing that's important, like kind of I should note, is that our program actually, for a while, we actually called it Data Analytics Masters, and we kind of decided that, again, the high-level umbrella very often, is data science, and also we are quite technical. We do a lot of kind of, there's a lot of very, statistics and math-based courses, and also more on the engineering side. So, probably we decided that, the data science name was probably more appropriate for the program. In general, I would say analytics very often is going to kind of focus a little bit more business facing, conveying to managers, that then these are kind of maybe some non-technical people that you may need to convey data to. So visualization, super important. But I will also say, going back to the slide on this, oops, so here, is, very often any skill can be used in any job. And very often you will see these kind of posts for data science, but you're doing visualization, or data engineering, even maybe you're doing data visualization. But again, these are kind of the groupings that I would often see. Visualization is really kind of a skill, and I would say normally it's going to be somewhere between analytics and data science, most commonly. Okay.
Can I just
So
jump in there, Tyler?
Yeah.
I didn't introduce myself before, but hi, everybody. My name's Colleen Tapalia, and I work in the admission area here at Clarkson. I just wanted to point out, for people who are more interested in the analytics than the data science, we have a program in MBA in business analytics. So sometimes programs have a little bit of overlapping area, and certainly anyone who does the MBA in business analytics would be enrolled in some of the same courses as data science, especially on the elective side. So we're providing a lot of content that students can use in either of these two disciplines. So what you learned today will stand you in good stead if you decide to apply for the MBA in business analytics, which is also a STEM degree.
Yeah, thank you, Colin. Yeah, I didn't see you in there. There's so many folks that you were buried in the chat. But no, yeah, and Colleen's really great. She has a lot of information about kind of some of the kind of more application side things, and the different programs. I know we have like kind of a dual degree. We'll have MBA students. I actually have, and one of the things I wanted to mention is I have actually a lot of students from various other research and PhD programs. These could be from engineering that take my class, and sometimes our data analytics or data science students end up working with them. So that's kind of a cool experience too. And I know, Sumona, you said your PhD students will often work with the master's students. So that's really fun. Yeah, so I'll open it up for any questions that people have.
So
I
hi,
see
team.
Pavitra.
Yeah,
Hello, Pavitra. Good to see you.
Hi, Sumona, and hi, Colleen. I'm so happy to see all of you here and meet your new colleagues too. And yes, we do have a lot of questions from our students. And thank you for that excellent presentation, by the way. I was very happy with the clarity that you gave. The Venn diagram that distinguished data science, data engineering, right? Data visualization is so crucial because a lot of our students do not understand the different aspects and how they relate to each other, right? And I have to say, you actually helped us visualize it so effectively. It was almost recursive in its nature,
Yeah. So I will actually share a link. I have a small audio. It's from a former student and we actually talk about this, and we actually go through different jobs, and we actually discuss the difference. So I'll make that available for people.
That would be extremely helpful because
And the
a
slides
lot
also.
of people do not have the clarity, right? And that would be great. So thank you so much. And yes, I do have some questions lined up from our students. Excuse me. So let me start with the questions. Perhaps you might have addressed some of them in your presentation, but we have actually compiled them. Now, this is as you know, there's so many things on the move right now in different areas, including especially data science and AI. But a lot of people want to know, as you are at the cutting edge and you're researchers in the field, what does the future of this field look like? What are the trends that you see, and what are the applications that you see?
I
Go
can
ahead,
start.
Sumona.
Anyone, please. Yes.
Yeah, because I'm from the statistics background, I will say the future is very bright. So if you have that analytical skills in your CV, and if you are interested in that, always the field of data science statistics is on high demand, because always the supply was much less. But at the same time, now the data scientists are becoming, they are getting expertise on this field. The jobs are huge in the sense everywhere they need a data scientist. I can give you an example. Every university now are looking for a data scientist. Forget about the industry. So they need somebody who can actually crunch their numbers. So they will take a master students in comparison to somebody who has worked with some data, right? We have no expertise. This is just an example. Then at the same time, health related problems are getting much popular and important at this age. So health analytics, epidemiology, public health, there is a huge need of the data scientist. They don't need to come from biology or health professional. They just need to know how to handle data. So that's what our students, our masters and PhD students from our math department who has statistics, public health, epidemiology background, they are getting jobs like very easily, very easily. Even, I mean, forget about industry. I think all the students from Indian contingent and like South Asian, they know how to get industry jobs. I'm just talking about the other aspect of it. You think about a job in a hospital, they need a data scientist to crunch their numbers. This is just one example. Even the programs are getting so much bigger. Every university is hiring data scientists as their instructor. So that is another aspect that we forget and we don't apply our students. I tell them, if you have interest in teaching, you are the one who will develop the future data scientist. So there are too many jobs, and of course, all the companies are there to hire the data scientist. Tyler can talk more about that.
Yeah. Yeah, absolutely. So, I mean, from my side of things, I mean, I again focus really on a lot of the, infrastructure engineering part. And one thing that we have seen is that these sorts of roles tend to be more maybe less elastic in terms of the job market. So the reason is because if you're an organization that needs to store, I don't know, say you're Walmart and you have transaction receipts coming in, right? They need to be stored somewhere, right? So the infrastructure to store all of that stuff needs to be online. It needs to be available. And you can't just say, oh, you know what? We don't have a person in this role anymore. Let's turn that whole system off, because now you lose the last, week, and all of your other infrastructure may rely on having that to do demand forecasting, et cetera. So it's very hard to turn that off. And so because of that, right, very often you need people to work with data. Also, the scale. I think maybe people don't realize that many of these things are at such large scales that you really need to build your own tools to work with it. And this is all kind of reasons why people that do the data engineering stuff, I mean, sometimes people find it boring. I find it extremely fascinating, this idea of building infrastructure that's reliable and able to kind of take data, store it in a really intelligent way so that it's really able to be interpreted is hugely important. And I think it's a lot of that gets underestimated in terms of kind of the scope. I mean, there's this thing, you talk to anyone in this industry and you say, how much time do you spend on data pre-processing and data transformation before a project? And usually they'll say something like 70 to 90% of the time in a project is spent just transforming the data before you even do the analytics or the machine learning or whatever. And even in machine learning, a lot of the time is spent doing EDA. So these skills are super important, and they compose a huge amount of the time. And so it takes a large number of people very often to do these sorts of roles.
That was great. You actually took us behind the scenes. It's something like the data scientists tend to, it's like in a movie, right? you often think that the only people working are the ones that you see on screen, whereas there's a whole team working behind the scenes to make that experience happen, right?
Yeah.
So it was very
Yeah,
similar to that.
absolutely. Absolutely. So I think, I think there's a draw towards kind of the front facing stuff that people see and making the decisions. But so the traffic data that I have is a really good example. It's literally just a server with hundreds of thousands of files on it. So, okay, that's what you get. But at the end of the day, you have to make a case that says, hey, these vehicles are responsible for all the sound. Well, how do you get from that beginning point to the end point? It's not just, I think that there's this sense we all use very sophisticated software and phones and computers all day that will somehow just kind of transform itself. Well, no, it's not. You have to build tooling, right? There's a lot of tooling, custom tooling that needs to be built to do that transformation. And this is to another question that I just got in a private chat, right? So, how will AI affect kind of these sorts of roles? And I could talk for an eternity about this sort of thing, but one thing to kind of keep in mind is that so if you're talking about certain aspects of AI, right? These things are based on previous data, right? So stuff that's happened in the past. So number one, if your company is only using AI to drive its value, well, the company next to you is going to do the same thing, and you're not going to be able to compete against that, right? What's your advantage? And I mentioned that the human, right, is extremely important at doing the EDA, right? So this is the exploratory part of the machine learning process. And and because there's an extremely wide range, right? If you take, we look at the models and think, okay, they're really sophisticated and they can come up with these great insights. But you have to remember that it was a human that said, these are the inputs to the model, right? And that search is huge, right? If you're trying to predict, I don't know, like whether this patient should go home or not if they have pneumonia when they show up at the hospital, what inputs are you taking, right? So yeah, obviously we should take asthma and all these things, but the human has fed all of those things into the model. That deciding what those things are has already been done for the computer, right? So this is why this is actually pretty important. And I think that in a lot of really good student projects and work that I've seen done, the best work, the most kind of impressive work has been when somebody says, you know what, I have a little bit of experience with this, and I think that we should take this and put it into the model, or we should take this particular field and re-encode it. So I'll give you a really quick example of this. So one thing that we do is so there's a student project where they're trying to predict the price of used cars, and they have the model of the car, right? So there's sorry, the make. So it's like Toyota, Ford, GM, whatever. And so they usually can't put that into the model. The model doesn't really understand those things. So I said, okay, so how can we solve this? And one of the big ways that we solve this is we drop in a index of how valuable that brand is as a number, right, into the model. And this is really good because it encodes how the longevity of that brand into the value, right? So this is a thing that a human did, right, that is actually quite creative. And that's one thing I should mention, is that creativity is really important in this field. And that is a kind of, something that generally humans do much more well, especially in such a wide scope. So I would say, like, it's a long spiel about that, but those are just some things to think about. And also, right, it's important to students that are applying, like, creativity is huge, especially in our program. It may be a little bit different than kind of your undergrad experience. We do spend a lot of time doing very creative, fairly open-ended projects, and the best student projects and the best kind of outcome is that you are pretty creative with solutions, and that you convey those solutions very well to people. Those are really important success factors.
That actually gives an edge to the students who gets the job at the beginning, because
Yes.
everybody knows in the industry that you have done this coursework. What is different? What exactly or what else you have learned? So when they talk about their projects, people understand that that person actually knows the field. So that helps a lot.
Yeah. And those publications that you showed, Sumona, like,
Yeah.
and some of the projects in my class and projects we do in various courses serve as portfolio pieces for students. And
Yes.
those are really, in a lot of ways, I would say, as someone who has had to hire people right in this field, like that's a super huge talking point in an interview. It's a really, really good competitive advantage to have those projects. It's not just the, what grade did you,
Coursework. Yeah.
right? Exactly.
Wow, you have actually answered so many different questions, right till what to do to gain an edge, right, when applying for
Yeah.
jobs.
Yeah.
So that's
Yeah.
fantastic. And we might have some related questions coming up as well. So thank you so much for that. I really appreciate the perspective because you gave practical examples, right? It was not just gyan, as we say in India. It was
Yeah.
not just theory. You gave a lot of practical examples. So let's look at our next question. And I would love to hear any examples or suggestions for this one, because so this actually combines two questions. One is there are many students who want to become a data scientist but do not hail from a computer science background. What suggestions do you have for them? And the second part of the question is, what is the scope for scholarship for a student in general? Right now, I definitely there are differences between PhD and masters and so on. But and I've also heard that a student who is a data science student can actually can they be of use in other departments where they need such resources? So could you talk about these two aspects, please?
I will start, and I think then Colin can give a lot of information regarding that, as well, Tyler and Christine. So it is definitely a program for building data scientists. So we really did not make it for computer science major or for math major or for civil engineering major. It's technically for everybody. And we had students who came from medical background, like a psychology background. So I'm telling you the truth. You just need to be a hardworking student and open-minded and have the basic skills that we have already talked about: calculus, basic statistics, basic programming skills. That's it. After that, we have developed the core courses so that you can go to the next phase of the elective courses or a little bit more advanced level courses. It is the student who worked hard, they get success very easily. For sure, background doesn't matter. Background matters when a student is taking a statistics course with me. If that person is coming from a statistic background, he or she can do much better in that course. That's the only thing that the background helps. Otherwise, when that student takes a machine learning course, he or she has to do equal amount of work like other students. So background is not important. What is important is the focus, is the determination, and the hard work. Now coming to the scholarship part of it, we are still a program. We are giving really, taking students with really in less competitive price. I believe our program is of 36 credit hours. Each credit hour cost approximately $1,000. That means around $36,000 for the full program. And on top of that, depending on the student's background, experience, job experience, and everything else, we give scholarships. Of course, scholarships is very competitive. It's not that we can give a huge lot of them depending on the student's performance. So it ranges from 5 to, I will say, 15 or 17%. That is kind of the average right now. That is the scholarship amount. But there is a point when a student come here and he or she starts the program, we observe them very carefully. I'm telling you, Pavitra, each of us know each and every student, what they are doing. So this is our strategy. So we keep an eye on their courses, we keep an eye on how they're performing. If we find a student is doing fantastic, we'll go all out and provide all the help on the perspective of the scholarship. And we try to give some on-campus job opportunities because we need people for GA and TA work in different departments. I absorb a lot of students who can help in different undergraduate math courses. But again, everything depends on the performance. you have your acceptance based on your background. After that, all your performance will talk. Nothing else. Your background doesn't matter at that time. How you are performing in the courses, that will give you the increase in the scholarship opportunities in the TA or GA work. Colin can say a few things about that.
I talked to a lot of applicants, and I would say that about a third come from computer science or IT background. Maybe a third come from other engineering backgrounds. Maybe they don't love the stream that they're in, but they're quantitatively oriented, and data science is a great kind of pivot a little bit for them. And the other third might come from business, might come from other disciplines. We mentioned the co-director of the program, Dr. Boris Jukic. He always says, if you like spreadsheets, you can be successful. You just can't be afraid of numbers. So in that vein, if you do come from a discipline other than engineering or CS, which are the obvious ones, we have free prerequisite coursework that students can do prior to enrolling in the classes. And that's super important, not just for the students coming from other disciplines, but even students who've been away from formal education for a little while. They can do those prerequisites too, as kind of a refresher of the material that they're going to need to be successful in the program. When Sumona talks about what your background is, we're going to look carefully at your transcripts. And so we look at the semester-wise transcripts because we're paying attention to things like backlogs and repeated classes, things like that, as well as the overall CGPA. We don't require the GRE, but if you have good GRE scores, please include them in the application because that can only enhance your profile. And choose your recommenders wisely so that they can talk about your potential in this particular discipline, not just the kind of generic, this was a great student letter, but someone who can talk about your ability to conceptualize. Tyler was talking about the creativity that comes into play. It's not just crunching numbers, it's figuring out what story the numbers tell you. So if you can find people who speak to your abilities that way, all of those things will help create a strong profile for Clarkson, not just for admission, but also for the scholarship consideration.
Thank you so much, because that's extremely important to students, right? They want to make sure they can be successful at Clarkson and after. And I really appreciate what you talked about, Sumona. You also mentioned once, getting into Clarkson, it's about your background and your application and your profile, your essays and so on. But once you're here, it's the performance that matters.
Exactly.
Right?
That's the last word. Yeah.
Gives a very, very clear image. And thank you, Pauline, for the, 30, the 1/3, 1/3, 1/3 breakup. Right. That's extremely valuable. And I'm definitely going to please let Boris know that I am going to use his phrase. If you like spreadsheets, then you would do great at data science. I'm totally, because so many people, there are a lot of people who are otherwise very capable and talented, but might not be comfortable with spreadsheets or numbers or analytics. But because everybody wants to do data science nowadays, they also want to do data science. And I've always looked for a succinct way to pose a question that they can answer. And this was it. So thank you so much. And, the other couple of questions we had lined up, you had already answered all of them, right? So with, we for example, talked about the benefits, examples of different sectors being transformed, skills and tools required to excel. You covered all of that extremely well, Christine, Tyler, Sumona, what programming languages, tools, frameworks, pretty much everything you had covered, right? And also you spoke extensively about the career opportunities. So I think this was an extremely, wonderful session from you all. So I really do thank you for your time. And I will speak for a few more minutes about what Galvanize offers to our students. And that's totally optional to you if you, but I understand you're beginning a day And I'm sure you would, I totally understand if you want to see, how to get on with your day. But thank you very much for being here. And
Thank you. Thank you very much. And I just want to mention, so our contact information is there. I think you guys can, I'm happy to field, most questions from people. Couple people messaged me directly in the chat, so that's fine too. So if they want to reach out, I can answer additional questions or try to my best ability that I can.
Yeah.
So
And
yeah, and
Gautam is
that's
very active in LinkedIn. So we exchange messages
perfect.
very fast. I think that's a
I
good
am
way
not.
of-
Somebody asked me about
Oh,
LinkedIn,
okay.
and I
Okay.
I'm gonna be better about it. I promise. I
Okay.
realize I should be. So yeah, but in any case, right. So email is the most direct way, and
Yeah.
again, Colleen's email is there too about the actual program as well. Thank you very much.
Yeah, I will stay, Pavitra. I would like to
Okay.
learn more about
That's great.
Galvanize. Yeah.
Okay. And
Good.
Colleen, thank you so much. Lovely to see you. What a pleasant surprise. And Tyler and Christine, I heard a lot about you the presentation that Sumona made when she was in India. And she talked about you and she took us in detail through a project, a data science project on COVID. And
Wow.
a lot of students were inspired by the depth of the work you had all done. So
That's
thank you.
Yeah,
awesome.
that was a
That's
different
awesome.
presentation. Yeah.
Okay.
Yeah, that's awesome.
Yeah.
Great. All right. Well, thank you. Nice to meet you. And I appreciate everyone, with interest here. This has been great. And good questions. So have a good one. Take care.
Thank you very much, guys.
All right.
I'm just going to stay on to say that we are currently waiving application fees. So if you're looking for an answer on your application and you're just not sure, should I go ahead and give it a try? Put together the best possible application you can, and it will be reviewed by our faculty, and we would love to receive applications. We have 2 intakes a year, spring and fall. So right now we're looking at spring 2025 as we're about to start our fall semester. But it's not that long of a wait. It's just 4 months. So I encourage everyone who was interested by what they heard today to go ahead and put in an application.
You're on mute, Sumona.
Yeah, sorry. I mean, I'm telling my perspective because I was like you 19 years back. So if I get a chance to apply somewhere where I don't have to pay, I will do it for sure, just to see where I stand. Okay?
That's great.
Yeah.
Thank you. And we will definitely share that with a wider number of set of our student base as well. So that's great. Thank you so much, Colleen. Thanks for that. So I will move on to the next part and the last part of our session, and I'll try to keep it short. I just wanted to gather a quick feedback from all of you. What was your take on the information, the knowledge, the perspective that you gained from today's speakers? Just take 10 seconds. This is very important because they're here to share their experience with you, and honest feedback is what every presenter wants.
And this is the motive of learning. You need to criticize yourself. For us also, when we are presenting, we want to do much better next time. So your feedback is more important for us who had presented.
Great. Thank you so much for the poll. And I'm so happy to share 97% of our audience found the session helpful. So that's great, right? So coming back, I'm going to actually, so the last part, I'm going to very quickly walk you through what, through some of the students, some of our students at Galvanize Global Education that had done data science programs in different places. And you heard a lot from the Clarkson team today. You heard the professor's perspective. You heard the admissions perspective. Now I just want to show some profiles of different students. I've just picked a bunch of students, different universities, different countries for our audience, because we have students here from all over the place today with us, and I just wanted them to see what other students did. And I will very quickly show you. I'm not going to dwell on each profile. I just want you to see, what different students did, right? So this is one of our students from Bangalore. You can see her score, her TOEFL score, her test scores. She went for a master's in data science to Columbia. This is Abhilash. He's from information science and engineering. Here are his scores. Went to NYU. This is Ireland. The student Ketan from computer science background went for his master's in data science and analytics to Ireland. Again, you can see the profile. Now we picked another student whose aspiration was to study in Germany. He is from Visakhapatnam, studied at NIT Surathkal, which is in Karnataka. And he is now in Germany doing a master's in data analytics. Here is a student who wanted to go to Australia. This is Divya, did her bachelor's in computer science from BITS, and she is done her master's in data science at Monash in Australia. Here's a student who's doing her data science in London. This is Swati. You can see she's not from a computer science background. She did her undergrad in electronics and communications engineering, right? And she's gone to do her master's in big data science in at Queen Mary University of London, right? Here's another student who went from Kerala, studied at IIT Madras, went to Germany for his master's in data science. Now, the reason I'm showing you students who went to different countries is the data science is a trend all over the world. There are programs in different parts of the world, wherever you want to experience, right? And all universities offer that, right? So, how do you actually go about the process? And this is what we do at Galvanize. We will walk you through the steps, and let me see if I can actually show you a little bit. I'll try and do a show and tell if possible. So the most important thing for us at Galvanize is that we provide personalized guidance. You see, the study abroad space is very, very complex, right? Just because you have a lot of people wanting to study abroad and you have a lot of universities who want such students, the problem is what happens in the middle, right? In India, none of us has been asked to write an essay about ourselves, our academic journey, our professional journey, our ambitions, until we apply to a university in the US or elsewhere, right? So it is to fill these gaps that we offer very personalized guidance. And, whereas a student who's, let's say, done their bachelor's in the US, right? They would have already gone through this entire experience, right? So they don't need that level of guidance that we would need because this is the first time. Why? Because in India, most of the admissions are just based on a set of numbers, right? And it's not based on other things. So what we do at Galvanize is that we first evaluate your profile, meaning we understand a lot of things about you, including your academic background, your projects, your internships, your professional background, if any, your budget, your country preference, why you want to take this course, what is your short-term goal, what are your long-term goals. And based on our understanding that you will have with your admission counselor, we will shortlist universities for you. So your counselor will revert to you with a set of universities, maybe 12 or 15 or so, which are classified as ambitious, practical, and safe, based on his or her experience, based on their experience of guiding thousands of students, right? And in parallel, we would also gather a lot of inputs from you about your unique journey. And we will help you draft your resume, your statement of purpose, your letters of recommendation that your professors and project guide and internship managers would have to sign. We can guide you on how to go about the process with them, right? Because again, this is the first time you're going through all this. For example, some of you ask me, I already have a resume. Why do I need an SOP? Why do I need a statement of purpose? So the difference is a resume tells you what you did, where you did it, and when you did it. But it doesn't tell the reader, why did you do it? Why did you pick that particular project? What did you learn from that experience? And how did that change your decision making or influence the next set of things you wanted to do. So these are all expressed in an SOP, and that's why it's very important not to go with a templatized statement of purpose, but to always write your own statement of purpose, right? And that's why we are here, because it's not something we do often in India. We actually, that students are used to. We need professionals like us who gather the inputs from you, but help you draft it into a compelling narrative, which kind of answers all the questions that the university wants to learn about you, right? And then we will also help you customize this for different universities, depending on what questions each university wants to ask for your essays. So once you submit all your applications on time, and of course, we'll help answer any queries you have about the application forms, then it's fabulous news, because you will start getting the admissions. They'll be rolling in into your email inbox. And once you decide which university you want to take up, we will also guide you in terms of how to go about the visa process, what the visa interview process might be like at the US consulate or whichever country you're going to. What is the process for that? What are the paperwork that you need to take? And also we can guide you in terms of the financing. A lot of our students have been guided by us to help secure education loans at terms at very low interest rates, or in a way that suits their background. For example, if they're not able to pay some money up front, then we can try and get a loan that's 100%. Or if they don't have collateral, depending on the program, we can try and get you a loan provider who does it collateral free, which means you don't have to mortgage any property or anything like that. So there are all these different complications on the education loan and financing. We can guide you there as well. And finally, the pre-departure requirements that any student will have before they fly out abroad. So this is the end-to-end guidance that we do here at Galvanize, right? So I'm just going to show you real quick. I'm actually going to see if I can show you what our portal looks like, right? So if you can see, we have a whole bunch of students. They're from lots of different places. Okay, right now we have students from more than 194 cities, all of whom we are guiding for admissions counseling. Right. And you can see they're from different colleges, different institutes, different GPA. There's a 6.25 person right next to a 9.13% and all the way in between. Right. And they want to do different things. They want to study. These are some of the specializations. And you can see data science is generally quite popular. And so are, a lot of these specializations and countries that we have. So let me actually do this. Let me search for data science and see what that looks like, right? So here's just some of the students that we have guided for data science, right? So let me. Okay, so here's our students, different countries. Most popular destination is the US. And here are some of the universities that our students have gone to. And you can see that the program name can be different from one university to another, right? In one university, the data science can just come under the computer. It's a master's in data science, in computer science, with just a specialization in data science. So they don't explicitly call it a master's in data science. But I think Clarkson has done a fantastic move by calling it an MS in data science, because that's what a lot of people are actually looking for. And some universities actually go very, very way more granular. For example, Trent University in Canada, big data analytics, applied modeling, so on. So they make that degree sound a lot more specific. And, I guess that's a choice. And it also, but, do keep in mind that the name of your degree will have some bearing on the first job that you apply for, right? It opens more doors, or sometimes it can close a few. So that's also an important point. So these are all some different programs, as you can see. All of these come under data science. That's what I'm trying to tell you. And a lot of students sometimes they think that they don't understand that perspective necessarily, right? So these are just, and I can go on and on. So this is a huge list. I would actually like to show you one of our students who who went to Clarkson for a data program. This is Yoga Lakshmi. And so she basically said, look, I am switching majors. She wants to go into data analytics. She likes her work and she has never applied before. These are her test scores. This is her TOEFL score. That's a 79. You can see her scores. She's done her bachelor's at Velam. She has done a bachelor's in electronics and communication. So she has switched, but she wasn't too kicked about ECE. She wanted to move to data science. She did not have any backlogs. So you can see that we ask you a lot of questions about your profile, right? And whether you had any publications or presentations or internships. So she has done, she has 7 months of experience there as a software engineer. You can see her short-term goals, her long-term goals, right? And she's like, look, after a few, she definitely wants to work in her field, right? She says, I want to work on my course-related field. And maybe after a few years of working, I would like to do a PhD. So when we recommend universities, we want to make sure we take all your preferences into consideration. This is a budget. Then we ask you, hey, on what basis do you want us to pick universities for you, right? And I really like the fact that she used 2 of her 5 priorities for the subject, which means she wanted to go to a school that is really strong in data science, right? And the other criteria were secondary or tertiary to her, right? So this is something, this is just to give you an example of how we gather the information from the student, right? So that's, to give you, so for example, I'm just going to give you, these are some of the universities we suggested to her. We give you the deadlines. So let's take a look at what we said for Clarkson. Hey, we definitely agreed. She wanted to go to Clarkson, and we love the fact we said the approach to the program at Clarkson is application-based. Right? These are some of the strengths of the program. It's not very theoretical. A lot of universities take a theoretical approach. They give you assignments which are more where you work things out, where you derive theoretically, but you don't work with large data sets. Right? So there were great course offerings, and we gave some of the details. We gave all the application information, all the, the website, the research link, whatever information the university wants, right? So this is how you have to go about the process, right? So let me show you a couple of our other students. Now, this is a student who has already done a master's, right? And she wants to do a second master's. That's possible. In this case, they wanted to shift from aerospace to data science, right? That's quite possible, and it's perfectly okay, right? So this is something that you have to be very open about your internships. You have to talk about your projects, and based on that, we can guide you in different ways, right? So these are, for example, different universities, schools. So you can see they got accepted to at UTR LinkedIn and joined UIUC, right? University of Illinois Urbana-Champaign. So different people, right? So different choices. This is another student who's, their interest in data sciences, it can be applied to every industry. So the reason I'm going through all of this is to show you, once we gather your information, we can actually help you and help you by choosing the right, by shortlisting based on your preferences, right? So for example, let's come back to Yoga Lakshmi. You can see that she applied to these, and we also tell you what we think, are the different universities are suitable for you in different ways, right? So I just wanted to give you a real quick, overview into this. So so thanks a lot for attending our session today. I hope that gave you a perspective as to how you need to work with a counselor in a structured way. If it's, it can be anybody. It can be your elder sister, provided she has also gone through a similar process, has vetted or has done the journey, maybe for data science ideally, right? Because there's a lot of nuances that you want to consider, right? So do take advice. Make sure you're not the only person who sees your statement of purpose. You want to have different people look at it, give their perspective, but then don't show it to so many different people that you get confused with all sorts of contradictory advice. That also can happen. So end of the day, you do your masters. Most people do their masters once. And you want to make sure it's a program that's well selected, that gives you the experience that you so deserve, that prepares you for your career journey, right? Whatever your career is, it can be in academia, it can be in the industry, it can take you to research, it can take you to teaching. Make sure it prepares you for that experience, right? So, and that's what I really liked about interacting with the professors and the team at Clarkson today. You can see how career-oriented their program is, and the fact that it was put together in a multidisciplinary way by faculty from different departments, including business, including computer science, including mathematics and statistics. What more can you want? Like that's a dream program out there. So yeah, thank you so much, Sumona, for joining us. Please convey my thanks to your faculty as well. And with this, I would like to wrap up. Thank you, everybody, for having stayed with us for 1.5 hours. That's awesome. We still have so many of you, and I hope this was helpful. I would love to know some feedback if you have any. If you can share your feedback on the chat, if you want to share anything, ask any questions. We are happy. We are here. We are happy to answer.
There is a raised hand, Andrews. I mean,
Yes.
you can ask now if you
You
have
can
a
just share your video and ask your question, or you can just type your question, whatever works for you. I'm okay. Andrews Salapki, I have requested you to unmute so you can ask your question.
Yeah, I have unmuted my mic.
Okay, could you please share your video and ask your question?
All right, please. I will share my video.
Thank you. Which part of the world are you from?
The point is, I want to raise an issue. You were, as you were mentioning, in fact, we thank you very much for your presentation, and it's so straight to the
Part of the
point.
world are you from, Andrews?
Yeah, I'm from Ghana.
Okay, great. Lovely. What time
Yes,
is it now?
it's now 5 minutes after 3 in Ghana.
Oh, wow. Okay.
So, but I, for instance, I have a business background. I'm a lecturer. I teach at a university. I've been teaching accounting, finance, costing, and stuff. But well, in the first place, let me apologize for joining late. I was having challenges with my internet, so I couldn't get so much of the presentations. But at least the little that I had the privilege of joining, I had a lot of information from that. But the point is, I wanted to, at a point, they were saying I could easily cross from, that is, I can easily cross from, let's say, business background to that is data science background. And he was mentioning that if, for instance, if the person has knowledge in a spreadsheet, it makes it very easier. And unfortunately for me, I mean, that's my area. I like spreadsheets and stuff. So I wanted to find out clearly. I wanted him to re-echo and emphasize that how easy is it for somebody who has a business background to be able to cross to data science? Because I've seen that a lot of writings have come over, and most schools are now requiring data science. So I wanted to find out how easy is it for a business student to cross to data science, and if it crosses and comes, what are the prospects in terms of employment? What are the prospects for somebody who holds data science in the US or even in any other country?
Please.
Okay, I can start. So we have students from business background quite a lot. So the point we want to make, we teach everything in the courses from the scratch, no matter which background you are coming from. We have help through some GAs and TAs who are sitting in the offices to help you on solving the assignments problem, homework, and get ready. It is up to you how much effort you want to put together to get success. So the courses are developed such a way that everybody should be able to understand. And you will have a total edge because you are from the business background. Some of the courses that we have for database modeling, data warehousing, those are offered from the business school. So you will be already pro on those. You just need to focus a little bit on the courses on probability statistics, say machine learning, and say if you are taking human computer interaction. So those are the things just you need to put a little bit more effort. And after that, because of your background and because of this program, you will have a lot of opportunities to join different industries, right? So maybe you will not be fitted to an healthcare industry, but you are going to be fitted in an industry where your degree is very important. So you will definitely have an edge. And I tell all the students that if you put effort, there is no question that you will not be successful.
All right. Okay. Thank you very much.
And just to let you know, Andrews, we have 2 faculty members in our math department. One is from Ghana, one is from Nigeria. We have 3 students who are from, 2 of them are from Ghana and 1 of them from Nigeria. Just to let you know.
I'm grateful. I'm grateful.
Yes.
I'm grateful. What I will do is that I will also advertise your students here, the university here in Ghana. I happen to be as a lecturer, and most of the students are looking for the opportunity to come and further their education in the US. So with this, I will take the privilege to, in fact, I've been writing references for students almost all the time. I think some of your, I have written some of my students have also come there to the US through your school, but I don't know if they really attended. So I'll take the opportunity to
sure, absolutely. Thank you.
Advertise
I'll
advertise.
And you can also let them know about Galvanize Global Education to help them get to Clarkson.
All right. Yes. I will do that because I've been thank you. I will do that because I've been having interactions with you online and internet. So I will do that too, so that a lot of students will join because they are looking for the prospects to further their education abroad. And I think Galvanize is a very good agency, and I will recommend that too. So thank you very much for answering my question.
Thank you for joining us and asking your question. All
Thank
right.
you.
So I don't see any other raised hands today, and I hope everybody benefited from the session. I certainly did. I love the slide about how the same data is presented in different ways, leading people to, I'm so happy somebody is doing this work. It needs to be done and it needs to be shared. So thank you so much. Do let your colleagues know, Sumona, this was well appreciated.
Yes.
And
thank you. Yeah.
all of us enjoyed the session. And thank you, everybody from Galvanize Global Education. Wish you all a great week ahead. Success with your applications and
Yes.
with your master's, your PhD, with your academic journey and your professional career. So thank you. And Sumona, I look forward to meeting you again in
Yes,
person also.
Absolutely. Yes, thank you.
Okay.
And all the best to all of you, whatever future endeavors you are thinking about.